For centuries, medieval iron artifacts have defied the relentless march of time, often outlasting their modern counterparts by hundreds of years. We marvel at ancient gates, tools, and structures that show minimal signs of corrosion, while contemporary metal objects succumb to rust within mere seasons. This striking contrast between medieval longevity and rapid modern decay presents a fascinating puzzle. It was not magic that preserved these ancient metals, but rather a testament to a profound, almost lost, understanding of craftsmanship and material science. The secrets lie in a combination of superior materials, meticulous processes, and thoughtful design choices. Modern manufacturing, driven by efficiency and cost, often overlooks these fundamental principles, leading to a significant oversight in durability. The primary difference in medieval iron's resilience begins with the iron itself. Medieval artisans predominantly utilized wrought iron, a material fundamentally distinct from the steel we commonly use today. Its production involved a laborious process of repeatedly heating and hammering iron ore. This intensive forging expelled many impurities, but crucially it left behind fibrous strands of slag, primarily silicate inclusions. These slag fibers were not defects. They were a key feature. They acted as a natural waterproofing agent, creating a layered, corrosion-resistant structure within the metal itself. This internal defense mechanism is largely absent in modern, purer, and more uniform steel. Beyond the raw material, the forging process played a crucial role in medieval iron's exceptional durability. Blacksmiths were not merely shaping metal, they were purifying and strengthening it through sheer labor. Each hammer strike and every heating and cooling cycle had a profound impact on the metal's internal structure. This relentless working compressed the slag fibers and closed internal voids, creating an incredibly dense, tightly packed microstructure. This process, known as work hardening, fundamentally altered the iron's resistance to environmental degradation. Modern manufacturing, in its pursuit of efficiency, often prioritizes chemical purity over this kind of mechanical density, sacrificing innate resilience. Medieval iron's longevity also stemmed from thoughtful design and effective protective measures that went beyond the metal's inherent properties. Artisans employed basic but remarkably effective coatings. Applications of oil and wax created hydrophobic layers, repelling moisture from the metal surface. Tar and specialized paints were also used to seal surfaces, providing additional barriers against the elements. Furthermore, the forging process itself often created a natural protective layer of iron oxide, specifically magnetite, which is far more stable than common rust. The primary purpose of all these coatings was to create robust barriers against moisture and oxygen, the main culprits behind rust formation. Environmental factors and a pragmatic design philosophy significantly contributed to this longevity. Iron elements were often strategically placed in sheltered positions or integrated deeply into stone structures, minimizing direct exposure to rain and humidity. The massive scale of medieval construction also meant that iron components were often thicker and more substantial, naturally taking longer to corrode. Finally, periodic maintenance, such as re-oiling or repainting, was a common practice for critical components, ensuring their continued protection. The extraordinary durability of medieval iron was not the result of a single factor, but rather a holistic approach. It was a powerful combination of superior material properties, intensive craftsmanship, clever protective treatments, and thoughtful design. Modern industrial processes, while incredibly efficient, often prioritize speed and cost-effectiveness above all else. This prioritization frequently sacrifices the innate durability that was once a hallmark of metalwork. The past holds invaluable lessons for our material future, reminding us that true longevity requires a deeper understanding of materials and a commitment to meticulous craftsmanship. By re-examining these ancient practices, we can gain profound insights into creating materials that truly stand the test of time.